Pi or pi. For many of us, pi is often the first transcendental number we encounter. Welcome to my presentation on the history of calculating the value of pi. Pi is one of the most fundamental constants in mathematics, embodying the ratio of a circle's circumference to its diameter. Understanding pi has been crucial for advancements in geometry, trigonometry, and numerous scientific and engineering fields. Today, we will embark on a journey through time, exploring how various civilizations and mathematicians have tackled the calculation of pi and observing the evolution of their methods. I'm Edward, your friendly storyteller. Ancient civilizations. Early estimates by Babylonians and Egyptians. Our journey begins with the ancient Babylonians and Egyptians around 2000 BCE. The Babylonians, known for their advanced mathematics, approximated pi to be around 3.125. This estimate came from their geometric calculations, as documented in Babylonian cuneiform tablets. Meanwhile, the Egyptians provided an approximation of pi as 3.1605, based on the Rhind papyrus. They used the formula for the area of a circle, implying pi as 16/9 squared, which is approximately 3.1605. These early estimates were remarkably close to the true value, showcasing the ingenuity of ancient mathematicians. Ancient Greece. Archimedes and the method of exhaustion. Moving forward to ancient Greece, we encounter one of the greatest mathematicians, Archimedes of Syracuse. Around 250 BCE, Archimedes used a method known as the method of exhaustion to approximate pi. This involved inscribing and circumscribing polygons within and around a circle. By calculating the perimeters of these polygons, Archimedes established upper and lower bounds for pi. With polygons up to 96 sides, he determined that pi lies between 3 plus 10 over 71 or 3.1408 and 3 plus 10 over 70 or 3.1429, a remarkably precise estimate for his time. Let's delve deeper into the polygonal method used by Archimedes. The idea is to inscribe a polygon within a circle and circumscribe a polygon around the circle. The perimeter of the inscribed polygon provides a lower bound for the circumference of the circle, while the perimeter of the circumscribed polygon provides an upper bound. By doubling the number of sides of these polygons, the perimeters get closer to the actual circumference of the circle. This iterative process refines the approximation of pi. Middle Ages contributions. Advances in China and India. During the Middle Ages, significant contributions to the calculation of pi came from mathematicians in China and India, who made remarkable advancements. Zhu Chongzhi, 429 to 501 CE. A Chinese mathematician and astronomer, Zhu Chongzhi used an innovative approach to calculate pi with exceptional accuracy for his time. He employed a 12,288-sided polygon to estimate pi, achieving a value between 3.141596 and 3.141597. Zhu Chongzhi is particularly famous for his fraction 355 over 113. Or 3.1415929235, known as Milu, which provides a very precise approximation of pi, accurate to 6 decimal places. This level of precision was unparalleled for over a millennium, demonstrating the advanced state of Chinese mathematics during this period. Aryabhata, 476 to 550 CE. An Indian mathematician and astronomer, Aryabhata provided an approximation of pi as 62,832 over 20,000 or 3.1416 in his work Aryabhatiya. Aryabhata's value of pi was derived from his formula for the circumference of a circle, reflecting his deep understanding of geometry. His work had a significant impact on subsequent Indian mathematicians and scholars, contributing to the rich mathematical tradition in India. These advancements highlight the global nature of mathematical progress during the Middle Ages, with significant contributions coming from both Eastern and Western civilizations. The work of Zhu Chongzhi and Aryabhata laid important groundwork for future calculations and showcased the sophistication of mathematical techniques in China and India. Islamic Golden Age. Contributions by Al-Khwarizmi. During the Islamic Golden Age, mathematicians made numerous advancements in various fields, including the calculation of pi. One notable figure was Al-Khwarizmi. Al-Khwarizmi, 780 to 850 CE. A Persian polymath, Al-Khwarizmi is often referred to as the father of algebra due to his groundbreaking work in that field. In his astronomical tables, Al-Khwarizmi included an approximation of pi as 3.1416, which was a significant contribution to the mathematical knowledge of his time. His work in algebra and arithmetic laid the foundation for many mathematical principles used today, and his methods influenced subsequent Islamic scholars and mathematicians. The translation of Al-Khwarizmi's works into Latin during the 12th century brought his methods to Europe, significantly impacting the development of mathematics in the Western world. The Islamic Golden Age was a period of remarkable scientific and mathematical achievements. Scholars like Al-Khwarizmi played a crucial role in preserving and expanding upon the knowledge of earlier civilizations, ultimately paving the way for the Renaissance in Europe. Renaissance and beyond. European mathematicians and further refinements. During the Renaissance, European mathematicians made significant strides in calculating pi. Let's explore the contributions of key figures from this period. Ludolf van Soelen, 1540 to 1610. Van Soelen was a German-Dutch mathematician who dedicated much of his life to calculating pi. He used the polygonal method, refining the technique by using polygons with up to 2 to the power of 62 sides. His calculations resulted in pi being known to 35 decimal places. These efforts were so valued that the digits were engraved on his tombstone. Van Soelen's work was instrumental in promoting the study of pi in Europe, and pi is sometimes referred to as Ludolf's number in his honor. John Wallis, 1616 to 1703. An English mathematician, Wallis introduced the Wallis product for pi in 1655, which was a new infinite product to approximate pi. Wallis's product was significant because it provided a completely new approach to understanding pi, moving away from geometric methods to an analytical one. This work laid the groundwork for future developments in calculus and the study of infinite series. Isaac Newton, 1643 to 1727. Isaac Newton revolutionized the calculation of pi in 1666 when he was just 23 years old. During a bubonic plague outbreak, Newton was homebound and made several groundbreaking discoveries, including a novel approach to calculating pi. Newton's application of the binomial theorem to non-integer values of n transformed the calculation of pi, marking the end of laborious polygon methods. His work highlights the importance of pushing the boundaries of established methods and reminds us that innovation can lead to profound breakthroughs. In summary, Newton's work not only changed how we calculate pi but also exemplified the enduring power of mathematics to transcend cultures and time. Leonhard Euler, 1707 to 1783. Euler made numerous contributions to the study of pi, including the introduction of the notation pi in 1737, which he adopted from William Jones. Euler's work on pi was extensive and included insights into its relationship with other mathematical constants and functions. His contributions laid the foundation for many future discoveries in number theory and analysis. Srinivasa Ramanujan, 1887 to 1920. An Indian mathematician, Ramanujan discovered rapidly converging series for pi in the early 20th century. His formulas were later used in computer algorithms to calculate pi to millions of decimal places. One famous series discovered by Ramanujan is on the slide. Ramanujan's series converged much faster than previous methods, significantly advancing the precision of pi calculations. These contributions from the Renaissance to the early 20th century highlight the diverse and innovative approaches mathematicians took to approximate pi. Each new method built upon the work of predecessors, demonstrating the cumulative nature of mathematical progress. In conclusion, the history of calculating pi is a fascinating journey through time, showcasing the ingenuity and persistence of mathematicians across different civilizations. From ancient Babylonians and Egyptians to modern-day algorithms, the quest to understand pi has driven mathematical innovation and discovery. Today, pi is known to trillions of decimal places, thanks to advanced computer algorithms and the contributions of brilliant mathematicians like Ramanujan. The study of pi continues to inspire new generations of mathematicians, highlighting the timeless nature of this mathematical constant. Thank you for joining us on this journey through the history of pi.